In this video, we'll be doing lesson 6-1, where we look at ratios and unit rates. A ratio is a comparison of two quantities by division. Something to note is that we will not use any mixed numbers. Always leave it as a fraction for this. Since we're doing ratios, which are a comparison by division, which means a fraction basically, we will have some improper fractions where the top is bigger than the bottom, but at no point do you want to turn it into a mixed number in this assignment or when you're doing ratios. So no mixed numbers. Make sure that you have that at the top of your page. There are a couple of different ways that you can write ratios. The first one is with the word 2 between them, so you could have like 10 to 15. The second way is with a colon between them. So you have 10 colon 15, or you can write it as a fraction, 10 over 15. Okay? So that first one that's being compared to the other one, the first one goes on the top, 2 goes on the bottom. Okay, same thing with variables. So we could write it as A to B, or we could write it as A colon B, or you can write it as a fraction, A over B, like they did in that one. Okay, so those are ways to write ratios. A rate is a ratio that compares quantities of different units. Okay, so a rate is something like 20 miles per hour. Okay, so it's comparing things that have different units. A unit rate is a rate with a denominator of 1. Okay, we're going to say divide the fraction. To get a denominator of 1, if you divide the top by bottom, right, you end up with a single number that could be written over 1. So to get a unit rate, you actually do the division. So let's pretend we were talking about 20 miles in 2 hours. Okay. To write this as a rate, you would say 20 miles over 2 hours, and you would leave it like that. To write this as a unit rate, you would do that division. So 20 divided by 2 is 10 miles per hour, and that is it written as a unit rate. Okay, but they are equal. Okay, so to write it as a rate, you leave it as a fraction, 20 miles over 2 hours. To write it as a unit rate, you would actually do the division of top divided by bottom, and you get 10, and you still have both units, so it's 10 miles over hours, 10 miles per hour. You could also write that as 10 miles over 1 hour. So see how it has a denominator of 1 now? That's what makes it a unit rate, because you've done that division and it can be written over 1. Okay, so that's the difference between rate and unit rate. Unit rate. You want to write it like this. Okay. A survey asked students whether they had after-school jobs. Write each ratio as a fraction in simplest form. So all students surveyed is the first part. Then we have that 2 from how we wrote them, and then students without jobs. So all students surveyed goes on the top because it comes before the word to, and then students without jobs goes on the bottom because it comes after. So before the to, after the to goes on the bottom. So if we look over here at this chart, it says all students surveyed. Total number is 100, so they put 100. Students without jobs, don't have a job, is 60, so we put 10 over 60. They want us to write each ratio as a fraction in simplest form. So we leave it in fraction form, but we need to simplify it. So what's something we can divide the top and bottom by? Right, if we do it divided by 20, then we're going to get to the smallest thing. So 100 divided by 20 is 5. 60 divided by 20 is 3. So 5 over 3 is going to be our answer. So again, all students surveyed goes on top. And then it says 2. So that's our fraction bar. Students with jobs goes on the bottom because it comes after the word to. So all students surveyed was 100. Students with jobs is 40. We can divide by 20 again. And on the top we have 5. And on the bottom we have 2. So notice that these are improper fractions, right? The top is bigger than the bottom. But we leave them that way because we're writing them as a ratio. So we don't want to make them into mixed numbers. We want to leave them as these fractions. All right, when you're ready, go ahead and flip your paper over to the back side. So the table shows prices for different packages of index cards. What size has the lowest unit cost? So we're going to figure out essentially how much within that pack each specific card costs. And we're going to do this by finding the unit cost, which means we're going to have those fractions and then divide them. So let's start with 100 cards. So we're using this chart over here. So 100 cards, we're going to put the price over the number of cards. The price is $2.70, goes on the top, over 100 cards. Okay? If I did the division and I said 2.70 divided by 100, because I want to turn this into a unit cost, which is the same as a unit rate, right? So that's where we're doing that division. Then I would get 0.027. Okay, when I do that division. So each individual card in that 100 pack costs 0.027 cents. All right, 50 cards. We're going to put the price over the amount again. So 50 cards is $1.30. If we divided $1.30 by 50, because we would divide the top by the bottom, then we would get 0.026. And then for the last one, we have 25 cards, and that costs 75 cents. So if we put 0.75 on the top, and we divided 0.75 by 25 cards, we would get 0.030. Okay, so we got to figure out which one's the smallest. So when we're looking at this, they all have zeros right after the decimal. Then they all have 2s right after the decimal. So, sorry, these two have 2s and this one has a 3, so that's not the smallest. Then we go to the next place value. Which one is smaller, the 6 or the 7, right? So that means that the lowest cost is going to be for 50 cards, because within that pack, each individual cost has the lowest unit cost. Again, we found the unit cost by making the ratio, or the rate, and then we did the division to get that actual unit cost. Okay, they also throw in some conversion stuff in here, similar to what we did in a previous lesson. We're not going to use their boxes because their boxes kill mosquito a little bit. So we're going to go from 30 gallons per minute to cups per second. So this is a little bit different than when we did it, because now there's two types of units, gallons per minute, and we want to go to cups per second. So what we need to do is we need to turn gallons into cups and minutes into seconds. So it's going to take more than one fraction with our conversion factors to do that. So this time, instead of setting it up with individual fractions, it's going to be easier if you set it up like this. So the first thing you should draw is this shape. So you have a line, and then you have two lines, and we're going to fill in each of these spaces between these. Okay, so that's going to be the easiest way to set it up. Now, we're starting with 30 gallons per minute. So we're going to say 30 gallons on top and 1 minute on the bottom, because we have 30 gallons per minute that we're starting with, 30 gallons over 1 minute. Gallons are on top, minutes are on bottom. We need to turn gallons into cups. Previous lesson, I believe, let's see, 5-5 maybe? Let's check. Yes, 5-5 has some of those conversion factors that you're going to need. So like how many cups are in a gallon and so on. If you use your previous notes, that will help you. Okay, so there are, well, let's start with the units. So if gallons is on top of the first section, then gallons is going to need to be on the bottom of the next one, right? If minutes is on the bottom of that one, the first one, minutes is going to need to be on the top of the last one, because we need to be able to cross these off, right? And then we're going to add the rest of the units. We're trying to go from gallons to cups. I'm trying to go from minutes to seconds. And then we go back and we add in our amounts. So remember, step 1 is like set it up. Step 2 is put the units for the other fractions. And then step 3 is add the amounts. This is all what we did in lesson 5-5. So there are 16 cups in 1 gallon, and there are 60 seconds in 1 minute. Okay, now I can simplify before I multiply. So gallons and gallons are gone. Minutes and minutes are gone. That's good. I'm left with cups per second, which is what I'm supposed to be left with. I have a 30 and I have a 60. So I could turn 30 into 1, right? 30 divided by 30 is 1. 60 divided by 30 is 2. I could second simplify, where I have a 2 down here and a 16 up there. So if I divide both those by 2, 16 divided by 2 is 8. 2 divided by 2 is 1. So now all I have on the bottom are ones and second, and on the top I have a 1, 8, 1, and cups. So when I multiply straight across, I have 1 times 8 times 1, which is just 8, and I have cups left on the top, over 1 times 1 times 1, which is just 1, and second is my unit, which is the same as writing it as 8 cups per second. 8 cups per second. Okay, so we converted 30 gallons per minute into 8 cups per second. We'll do a couple more of these down at the bottom as well. Okay, so for the first rounds of quick check, these are going to be the same from the chart on the other side. So have a job on the other side was 40 people. Don't have a job on the other side was 60. And total was 100. So you're going to use those numbers to help you build these fractions. Okay, so I'm going to actually have you do A and B on your own. Remember, the first fraction they want you to fill in has the original numbers. The second fraction would be your simplified version. So go ahead and fill in A and B for these, and then we'll come back together after you've paused your video and do them together. Okay, so the first one says students with jobs to all students surveyed. So students with jobs goes on top. Okay, so that would be 40. All students surveyed goes on the bottom, which is 100. If I divide the top and bottom by 20, I get 2 over 5 as my answer. For the last one, it says students without jobs, which was 60, to students with jobs, which is 40, so I have 60 over 40. If I again divide top and bottom by 20, I end up with 3 over 2. Okay, so it's just remembering that the ones before the word to go on top, the ones after the word to go on the bottom, and then you write them in the simplest fraction that you can. All right, find each unit rate. 2 liters of spring water costs $1.98. So we are going to have $1.98 on the top and 2 liters on the bottom. We're trying to write the unit rate, so that's the one where we do the division. So if I take 1.98 and I divide it by 2, I end up with 99 cents, 0.99 per liter. Okay, so you're just setting it up as a fraction. Excuse me, and then doing the division. So for B, you're going to do B on your own. You have miles and gallons, so you're going to have miles on top, gallons on the bottom, and you're going to end up with a answer that tells you how many miles per gallon that the car goes. So go ahead and pause your video and do that one, and then we'll come back together and do it together. Okay, so for this one, we should have 425 miles on the top, 12.5 gallons on the bottom. If I divide 425 by 12.5, I end up with 34 miles per gallon. All right, so we have 3.5 quarts per minute equals gallons per hour. So we're trying to turn quarts into gallons, and we're trying to turn minutes into hours. So remember that first step is to set up our chart here, and we're gonna have 3.5 quarts on the top over 1 minute on the bottom. Quarts is gonna go on the bottom of this one. Minutes goes on the top of that one. And I remember that because top to bottom, bottom to top means they're going to get crossed off. We're trying to turn quarts into gallons, and we're trying to turn minutes into hours. So we've now added the units that we're going to want to keep. After that, we go back and we add those quantities. There's 4 quarts in 1 gallon. There's 60 minutes in 1 hour. And now I'm ready to simplify. Quarts and quarts goes away. Minutes and minutes goes away. All I'm left with are gallons per hour, which is perfect. Are there things that I could simplify in terms of numbers? The answer is yes. 60 divided by 4 is 15. 4 divided by 4 is 1. Now all I have left on the bottom is ones, so that's going to be the end of my simplifying. So on the top, I have 3.5 times 1 times 15, which is going to get me 52.5, and gallons is my unit on top that's left, over 1 times 1 times 1 is just 1 hour, so I can write it like that, and then I can write it as 52.5 gallons per hour. All right, so for this last one, you're going from centimeters to meters, and you're going from seconds to hours. So go ahead and set that one up and try it on your own, and then we'll come back together after and check it. Okay, so step 1 is setting up our chart. 12 centimeters in 1 second. Centimeters was on top, so it goes on the bottom. Seconds was on the bottom, so it goes on the top. We're trying to turn centimeters into meters. We're trying to turn seconds into hours, so now all of my units are set up. I'm going to go back and I'm going to do my quantities. There are 100 centimeters in 1 meter. There are 3,600 seconds in 1 hour. Okay, so can I simplify? Yes. If I divide 100 by 100, I get 1. If I divide 36,000 by 100, I get 36. Now I have numbers on top, but only ones on the bottom. So 12 times 1 times 36 on the top is going to give me 432. Oops, I didn't cross off my units. Seconds and seconds are gone. Centimeters and centimeters are gone. So all that's left on the top is meters. Then on the bottom I have 1 times 1 times 1 hour. So all I have left is 432 meters per hour. And that wraps up lesson 6-1, where we were working with ratios and unit rates.